Hi class, this is the beginning of 9.6, solving radical and particularly square root equations by algebra. Now we began this in class with a Zoom meeting and it didn't get recorded, at least the first part of it. Now this first part that wasn't recorded was really short, so this video will be a short video. And the second part video was recorded in Zoom, and that's a little bit longer. It has more of the details. But I wanted to get things started here, and so that there would be a nice beginning to the end on this problem, on this chapter. So we're going to solve radicals, and specifically we're focusing on square root equations. And so if you turn in your book to page 370, they have this little description. So solving algebra equations is pretty consistently the same. Whatever you do to one side, do to the other. And you're trying to get x by itself, so you always undo things. So if you have 2x minus 7 equals 20, you undo the 7 by adding 7. Right, you guys have done so much of this that you're pretty familiar with this whole process. The only new thing you need to add in your skill set of algebra is how do you solve the radical part? How do you get rid of the square roots? And so, in order to get rid of the square root, you have to treat it like a function and undo the function, very similar to when we did exponentials and logs. We had to have the log be by itself so we could undo the exponential. We had to do the exponential by itself so we could undo the log. You're going to have the square root by itself. Isolate the square root. And once the square root is isolated, you can do a power on both sides. Raise both sides of the equation to a power. Now, if it's a square root, it's going to be second power. Second power will undo square roots. We aren't going to be doing much in the way of cube root equations, but if it was a cube root, you'd do a third power on both sides. Now there is one important principle here though, something that happens with the even ones. If you do a power, square roots have they're dysfunctional family of functions. They have problems with negatives inside, they have weird domains, and so square roots, fourth roots, even roots have problems. And because of those problems, you're going to have to check your answers. It's a must. You must check. Because squaring both sides may introduce extra answers that don't work. And if you watch the second video, it's going to explain that with this example. Here's an example to look for later. It comes up in the second video where I explain why an equation that has one answer can actually get two answers. And one of the two answers, of course, won't work because this only has one answer. Anyways, that's to come later. So we started this page 370 and we looked at a quick example, and then we went on to page 371 and we were starting to solve this problem. And we were thinking, okay, if you have a square root, how do you get x by itself? And so it is isolated. The square root is all alone, and you can do a second power on both sides. And the second power will cancel the square root. So you get x equals 49. Now you must check. We can check that and see that it works. So the second power is what undoes the square root. Now in class today, someone was suggesting, why don't we do a second power then? But the second power is a function that you have to do on the whole side. So if this is our equation, and we're going to do 3 times the square root of 4 minus x minus 7 equals 20. When we do the second power on one side, we're doing it on the whole side. And when we do the second power on the other side, it has to be on the whole side. You can't do second powers on pieces or individuals. It has to be on each side as a group. Now wait a minute, how do we do a power on a group? Question mark. Well, the only way to do a power on a group is to FOIL it. You have to take the first, second term and times the group again. Now wait a minute. The whole point of algebra is to try to make the equation simpler. Is this working? No way. If I FOIL this, this looks like a huge mess algebraically. No, there's something wrong here. And the thing that is going wrong, algebraically, it is correct. This is correct algebra. But it's not helpful algebra because we are making this problem blow up instead of get simpler. And the thing that went wrong here is right here. We did not isolate the radical. We have to get this square root by itself. Second powers are great for square roots, but second power is not so great for undoing -7. Something else is better for -7. Second power is not so great for timesing by 3. Something else is better to get rid of the timesing by 3. So this problem, the way I approached it here, was a false start, and I made a big mess for myself. So let's go back to the drawing board and figure out how can we solve this. So we got to isolate the square root by itself. This has to become alone. And if you want to see how to do that, watch the next video. That's part 2. That's where the Zoom class meeting picks up. Now forgive me, in the beginning of the Zoom class, at this point, that's where I discovered I hadn't recorded. So it's a little clumsy at the beginning. But we solved this one, plus we solved many others. Okay, so study hard on this one. Once you practice it, you'll find that you can do these, and they're pretty easy. All right, good luck with this, and study hard.